A domestic accelerator cluster running 50,000 chips in a single coordinated training job materialized inside a Chinese hyperscaler's data center within roughly one product cycle of Nvidia's export ban landing. That scale would have taken China's artificial intelligence industry 3 years to attempt under the conditions that existed before the restrictions. It happened in months. The question is not whether China built something. The question is whether what it built is accelerating faster than Nvidia can lock the door, and whether the gap is closing before the code catches up to the silicon. The contest runs across 4 dimensions: silicon, scale, software, and the one dimension where the domestic field is running against physics instead of against a competitor. The frontrunner is already on the track. Most analysts won't say its name out loud. Huawei's Ascend accelerator line, specifically the Ascend 910 generation and its successors, entered this race as the chip nobody in the Western press wanted to lead with, because naming it forces an uncomfortable admission. A sanctioned company, cut off from the most advanced manufacturing equipment and from Nvidia's own supply chain, is setting the pace for China's entire domestic field. That reluctance to name Ascend is itself a data point. It tells you how seriously the rest of the field is being taken. The reluctance to name the frontrunner is the sound of a gap closing faster than the official narrative has accounted for. Before the October 2022 export controls, Nvidia held the overwhelming majority of artificial intelligence accelerator deployments inside China. The H100 was the default specification for every serious Chinese hyperscaler and artificial intelligence lab. The installed base was not a number you competed against. It was the environment everything else ran inside. Even after the restrictions landed, Nvidia's existing stock in the form of A800 and H800 derivatives specifically configured for the Chinese market continued to circulate and process jobs. Nvidia's clock on this dimension was slow because it did not need to move. Incumbency is its own kind of lead. Think of it as a lap record set on a track that has since been closed to the record holder. The record still stands. Nobody is running against it. The track is unavailable. Into that closed track walked Ascend. Huawei's Ascend 910B became the first domestic chip that Chinese hyperscalers reported deploying at meaningful cluster scale. Reports from Baidu, Alibaba Cloud, and others suggest that Ascend-based deployments moved from pilot to production within roughly 2 years of the tightened export controls. Cambricon is present in the field with its machine learning unit series, deployed in some cloud inference tiers. MetaX has its C500 series attracting early evaluation contracts. But the deployment numbers publicly attributed to them are a fraction of Ascend's reported scale. No independent third-party audit confirms exact share figures. The picture is assembled from procurement disclosures, company claims, and analyst estimates. What those sources collectively suggest is directionally consistent. The field moved. Nvidia's clock on Chinese market share, effectively stationary, with the installed base accumulated over a decade and the export controls freezing new shipments rather than triggering a rapid response, because Nvidia's calculation was that the China market could not be served anyway. China's domestic field's clock, Ascend, moves from near zero meaningful hyperscaler deployment to reported production-scale clusters in roughly 24 months. The lead compresses not because Nvidia fell back, but because the domestic field learned to run the distance. Now, the harder question. Running the distance in small clusters is one thing. Frontier model training at the scale that produces the models that matter, the models that define the generation, requires tens of thousands of chips behaving as a single coordinated machine. Can the domestic field finish that lap? Nvidia's competitive position at scale is not just about a single chip's throughput. It is about the interconnect, the wiring between chips that lets thousands of accelerators act in concert. The reason frontier model training migrated to Nvidia hardware is that this fabric scales with the cluster in a way that preserves coherence. A 50,000 chip Nvidia cluster does not run 50,000 times the work of one chip, but it runs close enough that the economics and the science both work. That coherence is the product of a decade of co-design between silicon, software, and the network stack. It is not a feature you add at the end. Reports from Chinese artificial intelligence research circles and Chinese media, not yet independently benchmarked by Western analysts, suggest that Huawei's Ascend infrastructure combined with its own interconnect fabric, completed training runs at the scale of tens of thousands of chips without catastrophic failure rates. The company's own claims reference cluster deployments in the 50,000 chip range. I want to test this number directly because I think it is the most important number in this race, not because it proves compute parity with Nvidia, but because it proves the field can finish a lap. A chip that cannot sustain a frontier scale job is not in the race. It is a demonstration unit. Before this run, the credible domestic ceiling for a coherent training cluster was substantially lower. Crossing that threshold changed the category. 50,000 accelerator chips, pulled from their servers and laid end-to-end, would stretch more than 2 kilometers. Each one is drawing hundreds of watts. Keeping that array synchronized, every chip waiting for every other chip at the right microsecond, is not a hardware problem in isolation. It is a physics and engineering problem that Nvidia solved incrementally over years of iteration. The fact that a CEN-based infrastructure completed that problem, even imperfectly, is what moved the needle on this leg. A 50,000 chip training run is not a specification. It is a proof of fitness, like a distance runner completing a marathon, not to win, but to confirm they belong on the start line of the next race. The time matters less than the finish. Nvidia's clock on cluster coherence at scale, set over roughly a decade of interconnect iteration, now at a level where 10,000 to 100,000 accelerator training runs are the routine operating envelope for top-tier customers. China's domestic field's clock. CEN-based clusters reportedly crossed the 50,000 chip threshold within approximately 2 to 3 years of serious domestic investment following the restrictions. The gap in raw coherence performance is still real. The gap in whether the field can finish the lap has closed from cannot complete the distance to can complete the distance, slower. Those are different categories. The field is now in the second one. Finishing in silicon and finishing in code are different races. And the code race is the one where CEN's clock looks nothing like it does on the previous 2 legs. CUDA is not a programming language. It is 20 years of accumulated decisions made by researchers who chose the easier path, and the easier path was always Nvidia's. Every model architecture, every training library, every fine-tuning tool, every inference optimization written in the last decade has CUDA assumptions baked into its lowest layers. PyTorch runs on CUDA by default. The open-source model weights released by every major laboratory were trained on CUDA hardware. When a Chinese artificial intelligence team inherits a model from a Western laboratory, or from a domestic laboratory that used Nvidia hardware before the restrictions, they inherit a CUDA dependency. Switching accelerator hardware is not a driver update. It is a recompilation problem that cascades through every layer of the stack. Huawei's CANN, which stands for Compute Architecture for Neural Networks, is its answer to CUDA. The company claims compatibility with major frameworks including PyTorch and MindSpore, its own domestic framework. Cambricon has its own software layer called Bang-C, targeting its machine learning unit hardware. MetaX is building an environment called MACA, positioned explicitly as a CUDA-compatible interface. Reports from Chinese developers suggest that model porting from CUDA to these alternatives is possible, but requires non-trivial engineering effort per model, and that performance on ported models frequently falls below what the same model achieves on Nvidia hardware, sometimes significantly. No independent benchmark suite has comprehensively confirmed parity on frontier workloads. The company's own benchmarks show favorable numbers on specific tasks. The broader developer community's experience is more mixed. My honest read on the software leg. The gap here is not measured in months of remaining work. It is measured in the accumulated decisions of hundreds of thousands of researchers who optimize their careers and their code bases around CUDA. That is not a technical gap. It is a gravity well. CUDA is not a wall the domestic field has to climb over. It is a river the entire global artificial intelligence community has been swimming in for so long that most of them have forgotten the ground exists. Building a CUDA alternative is not about making a better river. It is about convincing people who have been swimming for 20 years to stand up. I do not think any single product cycle closes a gravity well. I do not think 3 product cycles close it. Nvidia's clock on software ecosystem depth. accumulated over roughly 2 decades, with the installed base of CUDA-optimized code representing an engineering debt that any competitor must pay just to enter the conversation. China's domestic fields clock, CANN, Bang C, and MACA are all functional. Developer adoption is growing, but the gap is not measured in months of work remaining. It is measured in the weight of existing choices, the gravity of a codebase that was not written for them and does not naturally want to run on them. This leg split does not compress on a chip schedule. It compresses on a generation of researchers' schedule. Before calling the pace on code, we need to check the one leg where the clock is not moving the way the others are, and where I want to brake hard rather than accelerate through the corner. Every leg so far has shown the domestic fields clock tightening against Nvidia's lead. Yield and node access are where that story reverses, and where the gap is not compressing at the same rate. China's chip output numbers are growing. SMIC is producing chips at advanced nodes by its own account. Huawei released a smartphone with a chip that independent teardowns identified as fabricated on a process approaching 7 nanometers. The narrative writes itself from there. If they can make that chip, they can make the accelerator. The inference feels tight. It is not. A smartphone chip and a frontier artificial intelligence accelerator are different problems at a fundamental level. The accelerator is larger, hotter, more power-hungry, and demands yields, the percentage of chips that actually work off the wafer, that are far more punishing to achieve at advanced nodes. Reports suggest SMIC's yields on its most advanced process are substantially lower than TSMC's equivalent. A low-yield process does not just cost more per chip. It limits the size of clusters you can build because you need more wafers to produce the same number of working chips, and the supply chain cannot absorb infinite wafer starts. The 50,000 chip cluster is impressive. A 500,000 chip cluster may be yield constrained in ways the current reports do not surface. The counter-argument deserves a fair hearing. Yield improves with time and volume. TSMC's early advanced nodes were not high yield either. Every fabrication facility that has ever reached high-volume production did so by running wafers until it understood the process, and China is running wafers. The absence of extreme ultraviolet lithography machines, which ASML makes and cannot ship to China under current export controls, is real. But the domestic field is not standing still on the process question. It is attempting multi-patterning workarounds with older deep ultraviolet equipment that the company's own claims suggest can approach nodes in the 5 to 7 nanometer range without extreme ultraviolet. No independent process expert has confirmed this at frontier scale, but the vector is not zero. The honest synthesis, yield and the node ceiling are the one leg where the domestic field is running against physics rather than against incumbency. Physics does not negotiate on a product cycle schedule. The gap here is real. It is not compressing at the rate of the hardware deployment leg or the cluster scale leg. And anyone who tells you the 50,000 chip training milestone closes the process node gap is reading the wrong split. The cluster proves the field can run. It does not prove the field can build the chips it needs to run faster. 12 months from now, Ascend-based clusters will almost certainly be larger and more widely deployed inside China's hyperscalers. CAN and the competing software stacks will have more model coverage, more optimized kernels, and more domestic developer hours behind them. Cambricon and MetaX will each have at least one flagship customer, claim that moves them from also in the field to credibly in the chase. Nvidia will not recover meaningful new China sales under current export controls, but its existing installed base will still be running a significant share of China's frontier model training jobs, because the software gravity has not shifted on a 12-month timeline. The process node ceiling will still be there. The yield gap will have narrowed, but will not have closed. My call: the domestic field crosses the hardware marker inside this 12-month window. Ascend in particular will be able to point to cluster-scale training runs that were impossible 2 years ago. But the finish line of this race is not a hardware marker. It is a software marker, the moment when a Chinese artificial intelligence team inherits a frontier workload and reaches for a domestic accelerator without hesitation. Not because Nvidia is unavailable, but because the domestic stack is the easier path. That moment is not 12 months away. The software gravity well does not empty on a chip schedule. What the legs of this race collectively tell you is that pace is not uniform across dimensions. China's hardware clock is moving fast. China's deployment clock is moving fast. China's software clock is moving at a different cadence entirely, not because the engineers are slower, but because software accumulates like sediment, and you cannot rush sediment with a product roadmap. Ascend is the frontrunner. It is running the fastest domestic clock on silicon. It proved the field could finish the distance. It set the pace that Cambricon and MetaX are now chasing. But the race is written in code, and in the code leg, Ascend is still in the back straight, not the home turn. The frontrunner, nobody will name, crossed the hardware line. The race that matters has not started yet. The question I want to leave you with is this. If the software gap is the real finish line, which clock hits zero first? The domestic stack reaching CUDA parity, or Nvidia finding a legal path back into the Chinese data center? One of those is a technical problem. The other is a geopolitical one. They are not on the same schedule, and they are not moving at the same pace. Drop your call in the comments. And if you want to watch both clocks in real time, the subscribe button is right there, and the notification bell will make sure you do not miss the next split.